Okay, this is lesson 121, and we're talking about piecewise functions. All right, a piecewise function is going to be a function that requires more than one equation to describe it because it looks different depending on where you are on the x-axis. All right, so if you look at this example here of a piecewise function, this part of it right here looks like a horizontal line where y equals -1. This other part here looks like a line that has a slope of 1 and probably a y-intercept of -2. And then this third part of the graph looks like another horizontal line. Right, so when you write the equation for this graph, what you have to do is take each part individually and figure out its equation. So the way we're going to write the equation for this graph is we're going to write what's happening in each situation as you go along the x-axis. All right, so first of all, we have this horizontal line, and it's y equals -1. That's going on if x is between 0 and 1. So as you go along with your x-coordinate, starting at 0 and going over to 1, that's what kind of graph you have. So that is if x is between 0 and 1. So that's how we would write that part of the graph. And then the second part of the graph is this slanted line. It has a slope up to over 2. So the slope of that line is 1. So remember to write the equation of a line. It's y equals mx plus b. And in this case, m is 1, slope is 1. And then the y-intercept we can find just by plugging in a point, like the point 2, 0, right there is on this graph. So y is 0, x is 2, then b is going to be -2. All right? So the equation of the slanted line there is y equals x minus 2. And that's going on here as x goes from 1 up to 3. So that's what's happening as we go from 1 to 3. So that's if x is less than or equal to, x is greater than or equal to 1 and less than or equal to 3. And then the next thing that's going on is we have this horizontal line, y equals 1, and that's happening for all the rest of the numbers on the x-axis. So as x goes from 3 to infinity. Okay, so this is how we'd write the equation for this piecewise function. We have to write a different equation for each section, and when we write the equation of it, we're looking at the x-axis and what's happening as we travel along that axis. What is happening to y? Okay, as we travel along the x-axis, what is happening to y in this function? It starts out at -1, then it begins to travel along this slanted line, and then it gets to this horizontal line. So that's a piecewise function. Okay, on this function, we can write the equations for this function. So there are two different things happening here. You have this slanted line. We can already see that the y-intercept is 0. And then if you would look at the slope of the line, you can see that the slope, if you start here and come down and over, that is going downhill, and I mean you can use the slope formula too. That is going to be y equals -7/8 x plus 0. Well, I'm not going to put plus 0, but anyway, the equation of that line is y equals -7/8 x. All right, so when I write the equations, all right, so that one's going to be y equals -7/8 x if x goes from -infinity, and you don't ever put less than or equal to when you're talking about infinity because nothing can ever reach infinity, and then less than or equal to 0. because you can see there's a closed dot on 0 for that part of the graph. So you would say less than or equal to 0. So that's what's going on with the graph as you go from negative infinity to 0 on your x-axis. And then the second part of the graph is just a horizontal line, y equals 6. So that line is what's going on if, and now x is going from 0 to positive infinity, but it's not including 0. So we would say 0 is less than x, which is less than infinity. So x is between 0 and infinity. That would be what's going on. Y equals 6 is what's going on. So that would be the equations for this piecewise function. Okay, so now we have the equations and we're going to draw the function. Okay, so this says that y equals 2 if we're going from negative infinity to 0 on our x-axis. All right, so y equals 2 is a horizontal line. And so that is going to go from negative infinity all the way and including 0. So there's going to be a dot there where x equals 0, and then as we go to the left, it's just going to be that horizontal line, y equals 2. And then the next thing that happens is that as we go from 0 to positive 2, not including 0, we're going to be dealing with the line y equals x. All right, so the line y equals x, if we were just looking at it, yeah, it's totally separate. It's totally different from that line. So it's not even going to be connected to it, kind of like the one we did last time. All right, so it says that as we go from 0 to 2 on the x-axis, not including 0, so put an open circle there. And as we go from there to 2, we have the line y equals x. The line y equals x goes through the origin, because it has a y-intercept of 0, and it has a slope of 1. So it looks like this. Up 1 over 1, up 1 over 1. And that's what's happening to this graph as we go on our x-axis from 0 to 2 and including 2, because it says less than or equal to 2. So that's what's happening in the second part of this graph. And then the last part, y equals 3 minus x, that's happening as we go from positive 2, not including 2, on the x-axis, all the way to infinity. So when we are at, so that is a line, this part right here is a line, y equals negative x plus 3. So that's the line that has y-intercept 3, so it'd be the line that would go through here, and then it has a slope of negative 1. So we're going to put an open circle on the place where we would be, where our y would be when our x would be 2, because we don't want to include x being 2. So in this equation, if x were 2, y would be 1. All right, so at that point right here, which would be on that equation if x could be 2, we'll put an open circle. And then from there, we'll draw the rest of what that line looks like. And so remember, that is the line that has a slope of negative 1. So that means we're going to go from that circle, we're going to go down 1, over 1, down 1, over 1. And so it'll look like this line as x goes from 2 to infinity. We have that line happening. Okay, so part of the reason we're talking about piecewise functions is because there's a really important function called the greatest integer function. And this is what it looks like. All right, this function has a special notation. It looks like this. Whenever you see those square brackets around x, it means wherever you are on your x-axis, so whatever x you pick, you are looking for the greatest integer that is less than x. All right, so for example, if you have f of x equals the greatest integer function, then what that means is if you see these little brackets around some number, like say you have 1.357. What that means is the greatest integer that is less than or equal to that number. All right, so 1.357, what's the greatest integer that's less than or equal to that? 1. Say you have 4 2/3 in that bracket. What is the greatest integer that is less than or equal to 4 2/3? That's 4. All right, so that's what greatest integer function means. All right, so you can see on the graph here what's happening. All right, if you look at, say, what's happening as you go on the x-axis from 0 to 1. No matter where you are on that little line right there, y is always 0, because 1/2, closest integer that is less than or equal to 1/2, is 0. The greatest integer that is less than or equal to 0.9999999 is 0. All right, so look up here. You have your like, say you have 4.5. Right? The greatest integer that is less than or equal to 4.5 is 4. Okay, so all the points on this little piece of the graph, y is always 4, 4, 4, because it doesn't matter what x is, as it goes all the way from 4 up to 5, whatever x is in this place here, 4.2, 4.99999, 4.876, 4.5, 4 3/4, all those places between 4 and 5, not including 5 and not including 4, well, including 4 actually, all those values are 4, because the greatest integer that is less than or equal to 4.5 is 4. Greatest integer less than or equal to 4.9 is 4. So y is always 4 as you go from 4 to 5 on the x-axis. Once you get to 5, y jumps up to 5, because now 5 is the greatest integer less than or equal to the next values on the x-axis. So that's called the greatest integer function, and that is what it looks like. And of course you can move it all around just like you would a parabola or a hyperbola. If you add or subtract something to x, say you have f of x is equal to greatest integer function of x minus 2. Say you have that function. Then everything is going to move 2 places to the right, just like it would if we subtracted 2 in the equation of a parabola from our x. All right, so if you have that function, then like this little piece of the graph is just going to move over 2 places to the right, and it'll be here. And so on. All of them would move over 2 places. Okay, or you could add something to the whole function, like greatest integer of x plus 2, and that would make all these guys move up 2. All these little horizontal lines. So you can move this function around the same way you can any other function. But that is called the greatest integer function.